Hi everyone. This is a video to show you how to use Excel to find probabilities. Now, this is very similar to the one that I just did previously for using the calculator, so some will be a repeat if you watch that video. But otherwise, if you're just starting out, let me explain. So when we're trying to find the probability that something occurs, something is less, some value. We're trying to find a probability of value. What we usually do is we take our we find a z-score. The z-score means a value on a standard normal curve that along the horizontal axis. A z-score of 0 means it's right at the mean, at the average. And then a z-score of 1 means it's one standard deviation to the right. A z-score of a -1 means it's one standard deviation to the left. So we would take our x, our value, our threshold, if you would, and we would subtract from it the mean of the population divided by the standard deviation, and we would get a z-score. How many standard deviations is this x value from the actual mean? Well, if we did that calculation and we came up with a z-score of 0.81, the question is, what's the probability of getting a value that is less than that z-score? Something less than. And probabilities are shown by the area under the curve because every single possibility is possible. So therefore, the total area under the curve is equal to 100% or the number 1. So how do I do this? So I'm looking for this. I've already calculated the z-score. So I put my mouse in any cell and I click on, I type equals, and I start to type normal, N-O-R, and all these choices come up. Well, the ones that you're going to want to be using with the standard normal curve is this one, this normal distribution. And so you'll see that if I click on it, puts it into the cell, and it tells me what needs to go in the parameters of it. X is the threshold, which is this line here, this z-score here. The mean of a standard normal curve is always 0. The standard deviation of a normal curve, one standard deviation is equal to one standard deviation, and cumulative means that's the way I'm calculating it. Now, if you want to see more information about that, just click on the function button and it will bring up the pieces so that you could actually just type, and it'll tell you if you need some more help with the function, it'll give you that information as well. Okay? So I'm not going to bother with that. I'm just going to type these in here. And I'm going to type equals. And I'm going to start with the normal, N-O-R, and it's going to come up, normal distribution. And so I'm going to click on that. I need my X. My X is the value on the horizontal line, which is 0.81. So I'll put in a 0.81 and then a comma. The mean is 0 because it's a standard distribution, comma, 1 standard deviation, and comma. Now, you'll notice that you can type in true or you could type in false, but since computers work in binary, you can use a zero for false and a 1 for true. I'm just going to put a 1 in there, okay? So this is a cumulative distribution from the left, and I'm going to press enter. And this tells me that the area under the curve to the left of this is 0.79103, or it means that 79% chance that a z-score will be less than that value. Okay. Now I can do the same thing if I want to know what's the probability of being something greater than. The trouble, though, with this particular app is that if I do type in the equals and I type in normal distribution, okay, and I start with the formula here, and I put in the negative 1.18, and I put in 0, and I put in 1, and cumulative 1, okay, I get only 11%. Now, that colored in area does not look like 11% of the area under the curve, but it does look like this little white area over here. So what does that tell me? It tells me that the formula only calculates to the left. It only calculates a value less than. It never will calculate a value greater than. So how can I adjust? Well, I can adjust by saying, I know that the whole area is 100% or 1, and I know that I want the right side of this border, not the left. And I know this gave me the left, so therefore I will put in 1 minus, and voila, I get the right answer, 88%. Now that looks right. Okay. Down here, I want between. Well, we already learned up here that I can't use the formula by itself. It always calculates to the right. So how can I do it if I want the value between? I'm only going to get the area to the right. Well, here's how you're going to do it. I'm going to take, okay, and can I draw? It's not going to let me draw. What I'll do it on this one because I can do it here. What I'm going to do is I'm going to take the draw and I'm going to take the highlighter. And so what I'm going to do is I'm first going to find the area to the left of the one to the furthest right. So I'm going to find all of this area. Okay. And then once I found that area, I'm going to subtract away this area. And what's going to be left is the green area. Okay. So what I'm going to do is I'm going to take my formulas and I'm not going to type them all in this time. I'm just going to take these formulas and I'm going to copy and paste it over here. I'm going to type equals because you always have to start a formula with an equal sign. And I'm going to type in my, stretched out here so you can see it. Okay. So I'm going to take the area to the left of 1.24. And then I'm going to subtract this area to the left of negative 0.89. And that's what so the area that falls in between here is about 71%. And that makes sense. Okay. Now, we also need to find what if the reverse of this problem? What if I know the area? Okay. I know the area. I know the probability. So the question becomes, if I know the probability of being less than Z is 95% or 95.15%, what Z-score, what threshold gives me that? Well, there's a formula for that. And if I go to equals and I start with my normal, and okay, the next one down is the normal inverse. In other words, it flips problem. And it asks only for 3 things. The probability to the left, be careful, okay? Because remember, everything is cumulative from the left over to the center, to the point. The area to the left, comma, the area to the left, which is 0.9515, comma, the mean of a standard normal curve is 0. The mean of the standard deviation of a standard normal curve is 1. And so the z-score that must be is 1.66. So it is, remember, the z-score at the very center is 0. So at positive 1.66 is the border out here. So if 95% of all possible values for z-score are less than this number is 1.66 rounded. And in the same token, I have to be careful if I've given the opposite. If I know the probability of something being greater than z, okay, then I need to do something because the formula only works when I know the area is less than. Well, and again, I will just copy and paste this one. What I'm going to do is I'm going to type equals and I'm going to put in the normal formula and it's normal dot inverse, but this time I have to write what the area is to the left of that point, not the right of that point. And so therefore I do 1, meaning 100%, minus the 39%, and that gives me this area. Now you could calculate it first if you wanted to, or you could just use the formula to let you do that. Okay? So those are the basics I will do another video where if it's not a standard normal curve, but what if it is all you have is the x? Is there a shortcut that I could use instead of having to convert it first to a z-score? Can I go right for it? And the answer is yes. And that will be in the next video.